Here we are one more time. We're going to begin into chapter 6, section 2 today. So we're talking about the normal distribution, and the focus of this section is on applications of the normal distribution. So the important formula that we're going to recall, we know how to compute a z-score. Over here, I put the verbal formula. It's the value from the distribution minus the mean of the distribution, all divided by the standard deviation of that distribution. And so here, if we're looking at our population, the x is the value minus mu is the mean, all divided by sigma is the standard deviation. All right, so I was going to just show you the example of the book. It's here on page, I forget what page it is. No, just kidding. It is here on page 328. I can't quite get it on there. Okay, so I'm just going to recreate that picture for us. Here it is, roughly like that. It is on page 328, and so here we have a normal distribution. Okay. The bottom numbers are, let's pretend this is the original data set. The mean is right smack in the middle. It's also the median and the mode. Let's suppose it is 100. And then here we're counting away by increments of the standard deviation. So here it looks like our standard deviation is 15. So if we move from 100 up to 115, that would be our value, 15 that I'm getting there. All right. And so basically what we can see here is what the standard normal distribution does is it takes our x value and basically, instead of looking at the specific graph for that particular normal distribution, remember the horrible, complicated mathematical formula that I introduced in the last section that I said, we won't use this, I promise. Well, that's because we have all of the values for our standard normal distribution. And so what we will do with that basically is what this is kind of envisioning for us is here we're taking our x value, 130, for example. We're subtracting the mean from that distribution, so that's 100. So 130 minus 100 is 30. And we're dividing by what? We're dividing by sigma. And that is the standard deviation of this distribution. So dividing 30 by 15, that gives us 2. Notice that is exactly how we compute the z-score. And that is exactly the value that we will plug in the standard normal distribution. So basically, any normal distribution can be converted into the standard distribution basically by just readjusting the size of this. So it might be taller in the middle, it might be shifted over to a different value because distributions will have different averages. So this doesn't have to be centered at 100. And then, you know, the spread of this might be wider or might be narrower, depending on what the standard deviation is. So these are the important steps in terms of the procedure that we're going to be following. Let me scoot table E out of the way a little second. All right, there's steps for finding the area underneath a normal curve or finding the probability associated with a particular x value are to, number one, sketch the distribution and the shaded in area that we are interested in. Okay. Number two, very important, we always have to convert our x to a z value, right? And then after that, find the area. Now in the book it says you can use a table or a calculator or a computer, but we'll be sticking to good old table E here. All right. So let's begin. with just a brief example. We'll look at example 6-6. I'm going to go ahead and grab the book really quickly here so I can tell you what page it is on and just give you the general idea. I cheated and sneaked and looked at it ahead of time and wrote down the pertinent information, but then I threw the book in the trash. No, just kidding. Here it is. All right. This one, example 6-6, says we're talking about liters of blood. An adult has on average 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. Okay. All right, and you can see step one, they already looked at for us in terms of the procedure. Here, notice step 0, I gleaned out the pertinent information from the problem. I wrote down mu is equal to 5.2. All of these should be, having units of measurement, so that should be 5.2 liters. Sigma, that told us the standard deviation was 0.3, and that would also be in liters. And then here, X is 5.4. They asked us what percentage of the population has less than 5.4 liters of blood. All right, so the first thing that we're going to do is sketch the distribution, right? So here's our normal distribution. It looks exactly like the standard normal distribution, okay? And because we're going to be using the standard normal distribution, in other words, we're going to be plugging in a z-score instead of just the raw x score, we're going to just assume that this is the standard normal distribution. You can do that. All right, so here is value 5.4 is greater than 5.2, so the z-score is going to be positive. It's going to be to the right of 0. And I'll just draw this as this. It's just a rough sketch where I've shaded in all of the people who have less volume of blood than 5.4 liters. And here, we can kind of go back and forth between the standard normal distribution and our specific normal distribution. If you want to, you can remind yourself this is the x value, this is 5.4, and this wouldn't be 0, this would be the average for our distribution, our particular distribution would be 5.2. I'll see that. Rats. Okay. Anyhow, there's our step 1, we sketched it. Step 2, we have to calculate our z-score. So let's go ahead and do that. Our z value we'll get by doing x minus mu all divided by sigma. I am certainly not just looking at the top of my page where I had that written down. I am reciting that from memory, of course. Okay, so this is 5.4 in place of x minus 5.2 in place of mu, all divided by 0.3, not 0.03, 0.3 for sigma. And letting our calculator do that for us. All right, divided by 0.3 equals 0.666, repeating. And our z-score, we can only accept out to the hundredths place. So here we will round this to 0.67. All right, and then using our familiar z table, we'll go ahead and plug in 0.6. I moved it the wrong way. Okay, 0.67 here. All right, so we can see that is 0.7486. So we find the area, 3, that's the third step, P of 0.67, because these are always going to be left areas, so that is short for z is less than 0.67. Okay, and that was 0.7486 or 74.86%. So we'll pause there and then continue with the next example later.